Hello everyone, in this video I am going to explain IUPAC nomenclature rules for acyclic compound. So while naming organic compound IUPAC name, there are 4 subparts. So I am dividing IUPAC nomenclature of total organic compounds into 4 parts, that is IUPAC of acyclic compound, IUPAC of cyclic compound, IUPAC of aromatic compound and substituted benzene, and IUPAC of bicyclo compound. I am dividing this topic into 4. In that, first one is IUPAC of acyclic compound. IUPAC of acyclic compound. This is what IUPAC of acyclic compound. So while writing IUPAC names of acyclic compound, we need to remember 7 rules. We must follow 7 rules. In that, one by one I am going to discuss first one. So what is first rule? First thing we have to remember, that is choose longest continuous carbon atoms chain. Carbon atoms chain as parent chain. So choose the longest continuous carbon atom chain as parent chain. So example. So if you see this one, if you see this example, there are 2 chains. This parent chain not necessarily to be straight. Parent chain need not to be straight. It may be straight or it may be branched, anything. So not necessarily to be a straight chain. So while see this chain 1, 2, 3, 4, 5, 6, 7. This is 7-membered ring. If you give number like this, then it become 1, 2, 3, 4. This become 5, 6, 7, 8. Then this one become parent chain, not this one. If you give number like this 1, 2, 3, 4, 5, 6, 7, 8, that is also correct. So first we have to select parent chain in given compound, given organic compound. So parent chain not necessarily to be a straight chain. Straight, it need not to be straight. It may be straight or it may be branched, anything. So if you give number like this, we are getting what your number is. So this is wrong method. I will give two examples separately, then 4, yes. Wrong method, right method, I need to show separately. So this is wrong. Which one is correct? 1, 2, 3, 4, 5, 6, 7, 8. This is parent chain. This is what parent chain. This is wrong. That is what right. Hope you understood. Then come to rule number 2. Rule number 2. If 2 chains with equal length are possible, if 2 longest chains with equal length are possible, two longest chains with equal length are possible, then the longest chain with more number of branches select as parent chain. So selection of parent chain like this. So see this example, you will get clarity. See, so I will give one wrong method, one right method. Okay, so what is wrong method? 1 2 3 4 5 6 7 1 2 3 4 5 6 7 both are correct, both are 7 member. 1 2 3 4 5 6 7 1 2 3 4 5 6 7 equal lengths are possible. Two chains with equal lengths are possible. If you give number like this 1 2 3 4 5 6 7, both chains are equal length. For same example, I am writing two methods, two numbers. So two different numbering. So if you see, this is wrong method. So this is said to be correct method, because for this one there is only one branch. This is the branch. For this chain, this is one branch and this is another branch. So how many branches here? Here number of branches are only one branch. Here two branches. That is why selection of this parent chain will become correct. Hope you understood. These are two rules while naming IUPAC, naming organic compound, acyclic compound. First we have to verify these two. Next, take screenshot. I am going to remove this. Rule number 3. Rule number 3 is lowest locant rule. What is lowest locant rule? While numbering carbon atoms of parent chain, the substituted carbon give minimum number, lowest number to substituted carbons. Locant carbon should get lowest number. That is the rule. So I am writing rule. While numbering carbon atoms of a parent chain, give lowest possible number lowest possible number to carbon atom containing substituent or substituted group. Right? So see this example. This is parent chain. Of course, it is containing carbon atom. Okay. If substituent is here at this position, so I give two methods, one right method, one wrong method, such that you understand easily. So if you give number 1, 2, 3, 4 like this, this become wrong. If you give number like this 1, 2, 3, 4 from right to left, this become correct. Why is second one correct? Because your locant carbon, substituted carbon getting number 2, your substituted carbon getting number 3. That's why this rule is omitted by this numbering, second type of numbering following this rule. First type of numbering omitting this rule. That's why this is wrong. Okay. Next, fourth one. Lowest sum rule. What is the lowest sum rule? See this, without giving for example, here substituent and here substituent. I will give one right method, one wrong method. Here substituent, like this. Then which type of numbering will be correct? So if 1, 2, 3, 4, 5, 6, 7, this one become wrong. 1, 2, 3, 4, 5, 6, 7. This one will become correct. Why? See this. If you give number, what are locant position? Second carbon is locant, fifth carbon is locant, and sixth carbon is locant. Sum become 2 plus 5, 7, 7 plus 6, 13. Sum become 13 here. If you give number like this, locant positions are 2 plus 3 plus 6, 2 plus 3, 5, 5 plus 6, 11. Lowest sum. This is what? Lowest sum. Locant positions sum become lowest. That is what? Lowest sum rule. Of course, this is in the part of this rule is in the part of what? First point of difference rule. So I am telling you that first point of difference rule, that includes this rule also. That means there is no significance for this one. Lowest sum rule has no significance because I will explain. First point difference rule. I will explain with it one example. I am taking bond line formula. Okay, here one methyl group, other methyl group, branch. So once verify structural representation of organic molecule in previous video. So if you give number like this 1, 2, 3, 4, 5, 6, 7, 8, 9. I will give one right method, one wrong method. For that I am taking 2 times. If you give number like this 1, 2, 3, 4, 5, 6, 7, 8, 9. Locant positions are, what are locant positions? 3 plus 3 plus 8, that become third position. On third position 2 times substituent, so 3 plus 3 at 8th position. So 3 plus 3 6, 6 plus 8 become 14. Here on second position 2 plus again 7th position 2 plus 7 9 plus 7 becomes 16. Even though this is correct, this is the lowest sum, but this method will be correct. This is wrong because your first point, see first point, don't think about sum. First point, so first point is what? 3. First point is low value, sorry, first point is here comparing 2 3, between 2 3 is high value. So first point is high. This is important, try to understand. First point is high, here first point is low. Even though the sum become high value, this method is correct. This method is correct. So see here what is first point? First point is 2, here first point is 2. Then go for next point. Second point is 3, second point is 5. So this one will become correct. Yes, this is correct, this is wrong. That means lowest sum rule included in first point difference rule. That is why there is no significance for this, but we regularly see this term lowest sum rule, that is included in first point difference, second point difference. In this way you can give priority, you can give numbering. Okay, this is fifth rule. Take a screenshot. Next, sixth rule. There are 7 rules. Sixth rule. This is sixth rule. Next one, seventh rule. What is sixth rule? Sixth rule is when same substituent present on parent chain, more than one time. Same substituent present more than one time. If same substituent present more than one time, then the number of times same substituent is present, the number of times same substituent is present is denoted with suitable prefixes or suitable terms, multiplying terms. They are suitable terms like di, tri, tetra, etc. Okay, that means see this. With one example, it will be very clear. CH3, CH here chlorine substituent, CH here chlorine is substituent again, CH3. What is IUPAC name for this? So 4 carbon atoms, so root word is but. 4 carbon atoms, so root word is but. In between carbon atom, single bond, so ane, but plus ane, butane. There are 2 substituents, chloro. When chlorine appear 2 times, use di. Dichloro. Chlorine appear 2 times, so dichloro. At which position? Second position, third position. Second position, third position. This become, what is the IUPAC name? 1,2 dichlorobutane. 1, 2 dichlorobutane. Using this di, this rule tells about when same substituent repeated 2 times, use di, the term di. If same substituent repeated 3 times, use tri, 4 times tetra, like that. So I am giving another example. If right, give number to the carbon atoms of parent chain 1, 2, 3. If you give number this is getting 4th position, 6th position. If you give number from right to left, this substituted carbon getting 2nd position, here 4th position. This one will become correct, 4. So 3, 4, 5, 6, 7. Then these two are not same. One is ethyl, one is methyl. Don't use the term di. If it is also methyl, then use the term dimethyl. One is ethyl, other is methyl. Don't use di. So that's my point. So if it is also methyl, then what you can write? 2, 2 at 2nd position and 4, 2 times methyl group, dimethyl. Total 7 carbon atoms, hept, single bond between those 2 carbon atoms, ane. 2, 4 dimethyl heptane. This is IUPAC name. And here, not this one. This one is IUPAC name. Okay. First do work like this. Then add all the terms, root word and prefix, primary suffix. Primary prefix, root word. This is primary prefix, root word, primary suffix. Add all those terms. Then you will get what? Complete name. So this is about the rule. So when same substituent is repeated, use the term di. If same substituent is appearing 3 times, use the term tri, like that. So I am going to remove this, take a screenshot. Next, going forward towards 7th rule, that is the last one in IUPAC nomenclature of acyclic compound. This is last rule for writing IUPAC nomenclature of acyclic compound, open chain compound. So that is 7th rule. 7th rule. What is 7th rule? When different substituents are present. When different substituents are present. When different substituents are present. When different substituents are present, then they are listed in alphabetical order. They are listed in alphabetical order. They are listed in alphabetical order. See example, you may get clarity. So CH3, CH what? Here Cl, CH2, CHBr, CH2 and CH3. So give number to the parent chain 1, 2 because 2nd position, 1, 2, 3. 3rd position, first point difference is this one 2, this one. If you give number left to right, this one 2. If you give number right to left, this one 3. So 1, 2, 3, 4, 5, 6. This is appropriate. This is appropriate method to give numbering. 1, 2, 3, 4, 5, 6 based on first point difference. Next, write root word. For 6 carbon atom, root word is hex. Between those 6 carbon atoms, single bond, so AN. Root word and primary suffix completed. What about primary prefix? There are 2 primary prefix, chloro and bromo. Which one we have to write first? They are listed in alphabetical order. Bromo beginning with letter B, chloro beginning with letter C. Between C and B, which one comes first in alphabet? B comes first. So, first write bromo. 4 bromo and 2 chloro. 2 chloro. So, final it becomes 4 bromo. Number and letters are separated by hyphen. 2 chloro. Don't give any space between hex, AN. So, this is IUPAC name of above acyclic compound. Hope you understood. So, like this, we can write IUPAC nomenclature. Here, we need to remember a note point. This is very important. Note point. The terms di, tri, tetra, etc. and what are terms? Next, secondary, tertiary and neo. These terms are not considerable, while alphabetizing substituents. However, iso and cyclo are considerable. See this? So, if same group appear 2 times, di, in alphabetical order, don't consider di. For example, if I try to give one example, suppose this is chlorine, this is hydrogen. Satisfy valency of carbon with hydrogen. 2 bonds means 2 hydrogen. So here 2 bonds means 2 hydrogen. Left to right 2 bonds means 2 hydrogen. Or if you take 1 bromine like this. Next, if you take 1 bromine like this, here 2 bonds means 2 hydrogen, 1 bond means 3 hydrogen. This is the compound. Numbering, first point difference rule. This is second position, 1, 2, 3. This is third position. So, give number like this, 3, 4, 5, 6, 7, 8. Forget about lowest sum rule, just first point difference rule on the basis of this one. So, how many carbon? Total 8 carbons. So, root word become oct plus between carbon atom single bond. So, AN. Root word and primary suffix completed. What about primary prefix? Chloro and bromo. Which one comes first? Bromo comes first. So, here how many bromine? 2 bromine. 5, 6 dibromo. This is one primary prefix. Other primary prefix is 2-chloro. 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 So this is the rule. So 5-6 numbers are not considerable. So bromo beginning with B, chloro beginning with C. Do not consider di. Do not consider di. So which one comes first? Bromo. So it is beginning with D, dibromo. Don't consider di, just use B, bromo, bromo. So that is the point. Di, tri, tetra, secondary, tertiary, neo are not considerable. However, what are considerable? Isocyclo are considerable. Hope you understood. So this become, so bromo comes first, B, alphabets between B and C, B comes first. So 5,6 dibromo, 5,6 dibromo and 2-chloro, 2-chlorooctane. So add all those primary prefix, root word and primary suffix, you get complete name of this compound. Hope you understood well. Thank you.